next one again. There's a typo on the first one here. It's not a to the m times b to the n. It's both of them need to be the letter a. They're both the letter a. Now, you should already know this property. You may not know it by its rule, but you should know what x cubed times x squared is. What is it? X to the fifth. So like terms, what did you do with the exponents? You added them. So a to the m times a to the n is a to the m plus n. You add exponents. By the way, that's an exponent. It's a superscript. It doesn't need to be on the same level as letter A. It needs to be above it. It's called a superscript in the exponential space. Now, this is a rule you're supposed to already know. A to the m raised to the n. You know, think about x squared that's to the fourth power. What would that be? X to the eighth. And a lot of you, you've done that stuff in the past. You have. What did you do with the 2 and the 4? You multiplied them. So when we have something with an exponent, we raise it again. We just multiply them. A to the mn. Here we have the power of a product. And notice there's no plus sign, minus sign in there. It's just two things being multiplied together. We are allowed to basically distribute that exponent in. So sum a times sum b all to the n is a to the n, b to the n. They both get the same exponent. Here's the negative exponent rule, and it's one of the most important ones there is, just because of how useful it is. Devin, you know this rule, but I don't know if anybody else does. Does anybody know this rule besides Devin? What are you saying there? Yeah. Something to the negative, a negative exponent is 1 over the same thing to a positive exponent. Is that what you meant there? Yeah. It's not really reciprocal.
Oh, I got the 0.
Now, another way of looking at this is if you had 1 over a to the negative n, you could be able to move that up top and make it positive. You have. Algebra 1. Everything in Algebra 2 comes from Algebra 1. This is the zero exponent rule. It's 1, good. A lot of kids will say this is 0, repeatedly. Give me a number.
5,000.
I'm going to raise it to the 0th power. You almost said it though, didn't you? You almost said 0. Anything raised to the 0th power is 1. Anything. Doesn't matter what it is. Take your mom, raise her to the 0th power, you get a 1 back. Anything. Quotient of powers. So this is not written as a fraction like it should be, but it's a over b, both to the m. What do you think we're allowed to do with that m? Distribute.
So AM over BM.
A to the m over b to the m. These are exponents. Don't say am over bm. Yeah, that's actually missing. We're going to add that one in. This one you may not know. It's the power of a quotient. I have this labeled differently. I have a raised to the p over r. What that is a, p stands for power, r stands for root. And a is just something, kids. But whatever this r is, it's saying take the root. In this case, it'd be the rth root of some a and raise it to that power p. Now another way of writing that same exact thing, you still take the rth root, but you keep the power inside the radical. And there is one missing. It's this one right here. Some a to some m sitting over some a to some n. Now multiplication, if you go back up top, the first thing we did, it was about addition. Division has to be about subtraction, because they're opposite actions. So a to the m minus n. Those are your exponent rules. It's about time you memorized them. I'll give you a new formula sheet tomorrow. I've got to add one thing to it. I left something off. And I guess you have a formula quiz sometime this week. I'd be going over the one you already got. All right, up next is demonstrating exponential rules. We do not evaluate any of them. Nobody cares what the number is. I don't want you to go to a calculator and figure it out. I just want you to show me that you understand what you're supposed to do. What you got, Stephen?
It's 4 to 6.
It's 4 to 6. How'd you do that?
You multiply the exponent.
Yeah, it's 4 up in the exponential space. A 2 times a 3. Twice a 3 is a 6. 4 to 6 is a huge number. That's why I really don't care that you write it out. Any questions on that? If you don't know what you're doing, we're just looking at the rules on the left, aren't we?
That'd be 64 to the credit bar.
That would be 64 squared. No, that'd be 16 cubed.
You add those? Huh?
It'd be 64 cubed.
No.
Or sorry, 16 cubed. 4 squared is 16.
No, it'd be,
Oh. Yes and no. It's not what I'm after here.
that's for -8. For 4.
No, I'm just working on exponent rules.
-8 to the third. Over -8 to the third. Heck, if I know, I'm guessing.
That's what it says. You guys just don't understand the understood. Everything in the world that you can see has an understood exponent. Of what, Stephen? 1. Somewhere down the line, somebody told you about things understood exponents. Everything has an understood exponent of 1. Everything. So this is actually -8 to the first times -8 cubed. And what are you supposed to do with those exponents? Add them. So it's -8 to what power? 4th. I don't want you to figure out what the numbers are. I just want you to show that you know exponent rules. I mean, if somebody was asking you to do this, you would grab a TI-84, wouldn't you? This is about learning your exponent rules, not figuring out what's there. 2/9 cubed. What you got, Chase?
You multiplied 2 times 3 on the first one. So did you add the exponents on the B?
Yeah, because this is something with an exponent raised again.
Okay, so like
It's this rule right here, power of a power.
do you do that every time like you do on B if there's not a number, if there's not an exponent?
You got to identify it with the rule.
That'd be 2/9.
Okay, I'm having an entirely different conversation with somebody else, aren't I? Aren't I? It's not y'all. I'm just tired of being interrupted. I'm so tired of this stupid crap where I have to repeat myself 1,000 times because I'm just trying to talk to Chase right now. Okay? Chase, this right here looks like the first property. Like terms with exponents. It says add. Okay? This here looks like the second property. Something with an exponent with another exponent. You have to follow what the rule says you do. That's what we're doing. Now, moving on to C, Aaron, what was your suggestion? That's exactly right. Because it looks like a property off to your left. It's down towards the bottom, quotient of powers. I think it's A over B all to the M. It says move that sucker on in. And I don't care what 2 cubed is, and I don't care what 9 cubed is. I really don't. That's the answer. What's D look like? What's that? Okay, how'd you do that? Yeah. 5 times 2 is 10, right? You use math, answer correct. But either way, you get 10/3. Don't use decimals with exponents, not until you get into exponential decay and stuff like that. Use fractions. Now, example E, a little interesting. Usually, this one wouldn't be a big deal to me if you squared 2, but we're not going to because it's going to clean itself out. You see anything special about this last example?
3
3 to 0. Anytime you see something to 0 to the power, what should you go ahead and make it? 1. That would be my first step.
And it's actually 4 to the negative 2.
The answer is not actually 4 to the negative 3 over 2. I told you don't to evaluate anything.
Well, if we were to evaluate, you can just drop that. Right?
Still a step ahead of you, bro.
Yeah, bro.
Now, the 1 doesn't matter, does it? What do you want to do with that negative 3/2?
Times it by 2.
Yeah. So we're doing 2. 2's cancel. Isn't there a rule that talks about negative exponents?
Yeah, it's 1.
1 what?
Over 2.
1 over 2/3, 2 cubed. We're just looking to the left at these rules of exponents. That's all we're doing. That's what you got to learn to do. When you do your homework, look at it. Look at those rules you've got written down. All right, and here's kind of the gist of what you do in here. A lot of times you'll see simple stuff like this on your ACT and EOC, obviously. Simplify in such a manner that all exponents are positive. So A is kind of funky and there's a 4 on the end, but that's not a big deal. Where's that 4 actually belong? In front. B4 is a vitamin. This is algebra 2. Put a 4 out front. Then you got this B times B times B stuff. What are you supposed to do with the exponents? Add them. So add them. Wrong.
When you reach 6.
6.
Yeah.
There's a B there that doesn't have an exponent given. What's it's understood? Start writing that stuff in. Or don't, and every time you're going to miss it, Stephen, because you're just going to say 5. You have a negative 2 plus a 7 plus a 1, don't you?
That's 6.
That's 6.
So the answer is B6.
4b to the 6th. Don't forget about the 4. Sorry, it's kind of all messed up. I don't seem to have a good pen today. 4b to the 6th. I'm not trying to confuse you by making that uppercase. My lowercase b's look like 6s, so that's why I made it uppercase. All right, how do you guys want to handle B?
When you do negative 3 times negative 2, so it's r to the 6 over 4 at x4. X is 4.
No. X to negative 8. Both pieces.
Oh.
You know with exponents, you have to give it to everything. Devin's mentioned that negative 8 on that x. He's wanting to move it up top, because if you move it up top, what happens to the exponent? It's positive. Now, I guarantee you, Miss Garner covered these rules with you. They're not new. They are heavily murdered and destroyed and just done whatever you can. Kids make up their own rules too. But if there was another rule, you'd be shown. And you're going to learn how to fix that next year when you retake me. Now, one of the things kids really need to do is they really need to understand that when you see numbers, work with numbers first. What do you got, Spencer? There's a rule right above that deals with negative exponents. Where is she? Yeah, right there. A to the negative n is 1 over a to the positive n. Or, I don't know if you wrote the or part, 1 over a to a negative n is a to a positive n. That's permitted. No, I know that doesn't make sense to you, but like if you take a half, take 1, and divide it by 2 raised to the negative third power, you're actually going to get positive 8. Because we're allowed to move that exponent up top and make it positive. It works numerically, it works for anything, variables or not. All right, anyways, if I was doing C, the very first thing I'd do is focus on numbers. 18 over 4, that reduces. What's it reduce to?
9 over 4.
Not 9 over 4, 9 over 2. The reason you do this is because most of the stuff is usually multiple choice.
Yeah.
Anyways, the reason you do this is because most of it's multiple choice, and you probably just made it a 50-50 question. Just by focusing on the numbers, the easy stuff. Now, I only see the m's up top, so m's are not a concern to me. There's an m to the 5th. I need to be concerned about these n's. There's a couple of different ways of doing this. I'm going to do this off to the side. One suggestion is to do this. Flip them. Makes them positive, because some kids have a lot better luck with positive than negative. Okay? And then you would invoke the subtraction rule, right? All right, so that'd be n to the 7 minus 3, which is n to the 4th. Now, Devin started off by saying subtraction. If you just follow the subtraction rule here, you'd have n to the negative 3 minus a negative 7. And what would you still get? N to the 4th. Now, that's a positive exponent. Where are you going to put it? Up top. Had we gotten a negative result, we'd have put it down low. It's a positive exponent. It goes up top. Most of the stuff you do without really even thinking about the rule, because you do it so many times through repetition, but it's about repetition too. I mean, if your repetition is just copying down somebody's work, you're not repeating anything. Plus, you're blind copy. God, that annoys me. All right. I'm going to skip this one. We got 4 minutes left. Backside, pick one. What scares you?
D.
Everybody always says D.
I wouldn't say D. Well, I'm sticking with D.
We'll do the one with fractions.
Number 8. Yeah, that's about right.
Anyways, D. One with fractions. Milbrath would reduce the fraction first at 9 over 30. It's 3 over 10. You should do that first, because if it's multiple choice, it's now 50-50. Promise you, it's 50-50. There's always something where they reduce the fraction wrong. And we'll focus on these other parts by themselves. You got x to the 2/3 sitting over an x to the negative 1/2. What rule do you invoke? Addition, subtraction? Subtraction. So x to the 2/3 what with that negative 1/2? Minusing a negative 1/2. Huh? Yeah. And I realize some of you guys suck with fractions. You got a TI-84 in front of you. You do 2/3 minus a negative 1/2. You can get the right answer. But anyways, 2/3 is 4/6. 1/2 is 3/6. 4/6 and 3/6 makes 7/6. It's positive. Put it up top. Next thing we see is we got this y to the negative 1/2 sitting over a y cubed. Now, personally, what I would do is I would look at it like this: 1 over y cubed minus a negative 1/2. You can take away from top or bottom, it doesn't matter. But if you take away from the bottom, you better write it like that. Why am I taking away from the bottom on this one? There's more down there. It's positive, kids. If you do that, you get 1 over y to the 7/2. Now, even if you don't see that you can do that, you can do this. You can just say, okay, y to the negative 1/2 minus 3. Go to your TI-84, whatever, punch that in, and you get y to the negative 7/2. That's a negative exponent. Turns out, where does it belong? In the bottom. It doesn't matter how you do it. As long as you understand the rules, you're going to put it in the right spot. By the way, it ends up down low where it belongs. And on this one, this D, there's more Z downstairs. It's a Z squared downstairs, Z to 3/4 upstairs. So what I would do is I'd think of that as 1 over. I'm doing the Z stuff off to the side here. 1 over Z to the second minus a 3/4. 2 is 8/4. 8/4 minus 3/4 is 5/4. And you're tuning me out when I'm sitting here trying to teach you a 5th grade math skill. Yes, son, it's 5th grade. The fractions aren't. Fractions 5th grade math. Has been since I took 5th grade in 80. What year was that? 88, 89?
Getting correct.
Oh, boy, that's
Huh?
That's the wrong voice. That's fire.
I don't even know what he's saying.
Oh.
I just
Look
tried-
it up.
Were you trying to find how many years it's been since you were in school?
No, I'm saying I learned fractions in 1989 when I was in 5th grade.
About 9.
Y'all. I seriously screwed the whole way.
I don't know what you were trying to imply. Anyways, that'll be it. Showing much more time. By the way, don't do these in one fell swoop. I mean, that's just a clear indication you went to photo math. You're not that good.
You're right.
Garrett, cheating is a sin. First Christ, I know better.
Really? Isn't that sound awful?
Of course it is. It's a sin everybody commits, but it's a sin. It's a-
church of Christ too, don't you?
Of course it is, because you're robbing yourself of the ability to do something.
What you be on your later?
Z to the 5/4 I'm thinking about.
I got some of you left.
I'm gonna pull on my 360 good. I appreciate it.
2 is 8/4 minus 3/4, 5/4.